I'm Justine Murphy with Vision Systems Design's Focus on Vision. There are a lot of exciting things happening in machine vision and imaging. Let's take a look. When the Ponte Morandi, a highway viaduct in Genoa, Italy, collapsed in 2018 during a rainstorm, 43 people were killed. Officials suspect the disaster was the result of insufficient maintenance. But such disasters could be alleviated or prevented altogether with the predictive maintenance capabilities of AI-enabled embedded vision technology. AI-enabled embedded vision setups can operate autonomously, triggering alerts for human intervention or initiating corrective action automatically, according to Konstantin Malinin, co-founder of MaxLab, an edge AI camera developer. Embedded processing systems can now offer enough capacity to perform advanced image processing tasks within a small footprint. Low-power embedded systems can also be battery-powered, with the battery being loaded by a small solar panel. And since the complete image processing happens within the camera, no data cables or wireless connection to a remote CPU are needed for the image processing itself. The system can communicate the outcome of the image analysis as low-bandwidth data via mobile networks. These embedded systems can easily be mounted on vehicles, like maintenance trains scanning railroad tracks or trucks monitoring road conditions, as well as on drones and airplanes for aerial imaging of long-range infrastructure. Machine vision technology can also enhance inspection of another element of critical infrastructure, asphalt or concrete pavement on high-speed roads like highways. One example is a system sold by Ames Engineering, a laser-based pavement measurement equipment developer in Iowa. Mounted on pickup trucks or other vehicles, the company's transverse profiling system collects information on the entire lane width. The system involves a laser line device that projects a line across the pavement at regular intervals as the truck travels down the highway. A high-speed camera captures images of that line at either 2048 or 4096 data points per profile, depending on the camera. This laser camera combination can capture the entire span of a lane of traffic. A 3D laser line device then transmits data to software. With Ames Engineering, the sensor and software can be integrated with location information from a GPS receiver that's mounted on the top of the truck. A network hub in the truck allows communication between components via an Ethernet connection. This year's Edge Awards, a Reader's Choice program presented by Vision Systems Design and a wide collection of other engineering brands owned by Endeavor Business Media, have been announced. Winner of the Machine Vision category is the Insight L38 from Cognex. It's an AI-enabled 3D vision system designed for ease of deployment, even for users with limited technical expertise. 2 honorees were also named in this category. One is Thea Technologies' IQ Lens Systems, which includes a motorized lens, motorized control board, and software designed for easy integration into automated vision systems. The other is the Lattice Sense AI Solution Stack, an FPGA-based machine learning solution from Lattice Semiconductor. Congratulations to all of this year's winners and honorees. And that's it for this edition of Focus on Vision. Be sure to like and share and subscribe to our YouTube channel. Follow us on social media and visit vision-systems.com to keep up with the most interesting and exciting news impacting the machine vision and imaging industry.